So from the first equation, we have that m to the c plus 1 equal to m to the 0. The second equation, we have that L to the a plus b minus 3c plus 1 equal to L to the 0. And the last equation, we have that t to the minus b minus 2 equal to t to the 0. So the important thing are the exponents. So from the first one, we have that c plus 1 equal to 0. From the second one, we have that a plus b minus 3c plus 1 equal to 0. And the last one, we have that minus b minus 2 equal to 0. So we can already solve for c. C, it is going to be to negative 1, and b, it is going to be equal to negative 2. So we have to replace c and b in the second equation. So that's it. So let me make a line here. So we have a plus b minus 3c plus 1 equal to 0. So a plus b, which is minus 2 minus 3 times c, and c, it is negative 1, so that's going to be plus 3 plus 1 equal to 0. So we have 3 plus 1, it is 4, minus 2, it is 2, and so therefore a, it is equal to negative 2. So we can conclude that from this expression, so this expression is our pi 1, so we have it also there. So let's replace the values of a, b, and c. So we have that pi 1, it is equal to L to the a, L to the negative 2, v to the b, b, it is negative 2, and c, and rho to the c. So rho to the c, which is negative 1, multiplied by f and f. So if we just put the negatives exponents in the denominator, so we have pi 1 equal to f divided by L, v, and rho, v square, L square, and rho to the power of 1. So we obtain the force coefficient. The only thing is 1/2 is missing. But we are not going to have this constant in the dimensional analysis. But if we know that the term in the denominator, if we divide it by 1/2, it is going to be the dynamic pressure. So that's why we usually add it. It won't change the variable. And remember that the relationship that we are going to find, it is a functional relationship. We actually have to do it experimentally. So dimensional analysis is not going to give us that function. It's only going to give us the variables that we need to use. But any variation, like multiplying by a constant, is not going to affect the final result. It's going to affect the dimensional function that we are not finding anywhere, that we have to do it experimentally. Okay, so we have one number left. So remember, we have L, U, and rho. Well, this L, V, and rho. It's a mistake in there. It's not U, it's V. Our repeated variables, we have to combine them with the viscosity now. So now we have to find the new A, new B, and new C, these new variables. Okay, so this is our expression for the dimensions. So L to the A, V to the B, rho to the C, and now viscosity multiplied by the viscosity, and that has to be equal to L, M, and T. But by now we know that what is important is we choose the base and we look to the exponent. So we have to choose A, B, and C such as the exponents are going to be cancelled. So let's start with, for example, the length. So length, for the case of the length, we have L to the A. So we have A, L to the B, plus b. So I'm not writing the base, just the exponent. And L to the negative 3, so minus 3c. And L to the negative 1, so minus 1, equal to, on the right hand side, L to the 0, so 0. Now we choose, for example, time. So we have t to the negative 1 to the power of b. So for time, the first one is minus b. Time, where is time? Is in there. Minus 1 equal to 0. And finally, mass. So we have m to the c. So for mass, we have minus c multiplied by m to the power of 1. So m plus 1 equal to 0. So from these two, we have that b, it is negative 1, and c, it is going to be negative 1. So we replace in the first case, so we replace this. So we have a plus b, which is minus 1, minus 3c, which is minus 1, minus 1 equal to 0. So we have a minus 1 plus 3 minus 1 equal to 0. So we have 3 positive minus 2, that will be 1 positive. We move it to the right hand side, it will be negative, so therefore a, it is going to be equal to negative 1 also. So our expression pi 2, it is going to be equal to L to the negative 1 velocity to the negative 1 density to the c, which is negative 1 multiplied by mu. Otherwise, pi 2 is equal to mu divided by L, V, and rho. So this is our second pi expression. And this is actually, in fact, 1 over Reynolds. So if we looked at the definition of Reynolds, so this is 1 over Reynolds. But no one works with 1 over Reynolds. So we just can modify it and have it instead saying, oh, okay, our new variable, it is just Reynolds. So we modify slightly the two-dimensional variables. So in the first case, we multiply or divide by 2. And in the second case, we took the reciprocal case, 1 over the pi number that we have. And so we can have a functional relationship. So the functional relationship will be a function of these two. Okay, so we have to check that the results are dimensional. That's step 7. So the force coefficient, it is equal to pi 1, which is F divided by rho V square L square. So whose dimensions are force, which is mass, multiplied by the acceleration, and density divided by density, which is mass divided by volume, and velocity squared. So velocity, it is length divided by time square, and length square, so 1 over length square. So they should cancel. So let's see. So we have a mass here, and this mass is cancelled with this mass. For the length, we have one length here and one length here, so we have 4. And so we have 2 length here because we have the power of 2, and 2 length here, so that's 4. So they cancel. And time, for the time, so we have t squared in the denominator and t squared in the numerator, so the dimensions are equal to 1. In the case of the Reynolds number, so we have Reynolds numbers if the second pi number, it is length, velocity, density divided by viscosity, whose dimensions are length, so which is length, multiplied by velocity, velocity is length over time, density, which is mass divided by length cubed, and viscosity, which is mass divided by length and divided by time. So the dimensions of these are, so we have L squared, L cubed, cancel with this L cubed. Mass in the numerator, mass in the denominator, cancel, and time in the denominator and time in the numerator, so the dimensions are 1. So we are right, okay? So we have to find our final expression. So we just we start from one relationship, so the force as a function of length, velocity, density, and viscosity. And so we transform this into a force coefficient, our pi1 number, equal to a function of a different functions of Reynolds number. Okay, we don't have information either about the initial function or either about the second function. We just reduce the number of variables. What happened if we took the original 1 over Reynolds? So if we decide to stay with 1 over Reynolds, so we have that we are going to have a different relationship in between these two functions. That's the only thing that is going to happen. Okay, let's have an example. Before some remarks, before jumping into the example. So remember, we do not provide the form of the function phi. It's a different function. Dimensional analysis reduces the function. Second, the desired pi terms can be rearranged. Remember, in the first case, we divided by 2, and it didn't change the fact that we have two new variables and a relationship to find out. Or we have Reynolds and 1 over Reynolds. And third, the order of the variables can be interchanged, so that's not a problem. Okay, let's now jump into our example. So we have a capillarity example. So in the capillarity example, we have a tube that is put into a fluid, and when we put the tube into the fluid, we find that the fluid actually rises. So the fluid actually rises up to some height h. Okay, and also we can notice that there is going to be an angle which is formed in between the fluid and the wall of the tube. So if the diameter of the tube is d, so we would like to find a relationship in between all these variables. So we have h as a function of the diameter of the tube, gravity, we consider gravity will be an important factor, rho, surface tension, and theta. So we gather that the surface tension will be an important factor as we look into that in the first chapter. So what do we have to do? List of the variables. So let's start by listing all the variables. Well, we have h, d, g, rho, gamma, and theta, the angle. And so let's find out the dimensions of all these variables. So L, it is going to be, well, h is going to be L, length, the diameter is also L, gravity is acceleration, Density, it is mass times volume divided by volume, L cubed. Surface tension, remember this is force per unit length. So force per unit length, it is going to be ml divided by L t square. So the second one, L over t square, it is acceleration divided by L. And finally, theta, the angle, which is dimensionless. So I just put a dash. So the number of variables that we have, it is 1, 2, 3, 4, 5, 6. So k, it is going to be equal to 6. K, it is going to be equal to 6. And the number of reference variables, so we have length, we have mass, and we have time. We have 3. So r, it is equal to 3. So k minus r, it is equal to 6 minus 3, which is equal to 3. And this is the number of pi variables. Okay, so the number of repeated variables, it is then therefore r is equal to 3. So the number of repeated variables are equal to 3. So we have to select 3 variables. So we are going to select, in this case, d, g, and rho. Why? Okay, let's have a look. So we have d, which is length. We have gravity, which has time, as opposed to d that only has length. And we have rho, which has mass. So each one of those, they have different variables. Well, d will have length, all of the three have length, but the second one has time and the third one has mass, which is not in the other one. So that's a good combination. Why we don't choose h? We don't choose h because it's the dependent variable, so we have to find the relationship for h as a function of something. So we keep h as a part, and so we can combine with the 3 original ones. So which ones are left? So we are left h and gamma and theta. Okay, so we are going to combine these variables. So our pi number, so pi 1, it is going to be equal to d to the a, rho to the b, g to the c, and multiply by h in the first case. Pi 2, it is going to be equal to d to the a hat. Let me put a hat to differentiate from the first case, because that is going to be different. Rho to the b hat and g to the c hat, multiplied by our second variable, which is gamma, so multiply by gamma. And in the third case, pi 3, it is an interesting case, because if we look to theta, the dimensions of theta are dimensionless, none. So in the third case, we already have our variable, so we are going to have theta. So we only have to do the exercise for pi 1 and pi 2. Okay. So let's do it for pi 1. So pi 1, it is going to be equal to d to the a, rho to the b, g to the c, multiplied by h. So in terms of dimensions, so we have L to the a, density, which is ml to the negative 3, everything to the power of b, g, which is length divided by time square, to the power of c, and h, which is a length, and that should be equal to ml and t to the 0. So let me move this a little bit. So that should be equal to ml t to the 0, 0, and 0. So let's start with the mass. So we start with the mass. So we have m to the b, and that's the only one. And that should be that b equal to 0. That's the equation for mass. Then continue with time. So time, we don't have time over here, so we have time just in this case. So we have minus 2c equal to 0. And let's continue with the length. So we have length. So we have L to the A, and we have length, and we have length. We have length, and we have length. So length. So we have L to the A. So we have A minus 3B plus C plus 1 equal to 0. So we have, in the first case, we already have B equal to 0, C equal to 0. So we just have to replace this one. So this is 0, this is 0. So A, it is equal to negative 1. So we have A is equal to negative 1. So our expression, so we have that pi 1, it is equal to d to the c to the negative 1, d to the negative 1, rho to the 0, g to the 0, multiplied by h. So basically we have h divided by d. That's the only two that survives. So this is our first pi term. Okay, let's do it now for the second one. So for the second one, remember we have pi 2 equal to d to the a, rho to the b, g to the c, gamma. So these are going to be new a, b, and c variables. So in terms of dimensions, so we have L to the a, m L to the minus 3 to the power of b, g, which is acceleration, L t to the negative 2 to the c, and gamma, which is m t to the negative 2 equal to m0, L0, and t0. So we have our three equations. So the equation for length, it is a minus 3b plus c equal to 0. For mass, so we have for mass, we have b, and we have plus 1 equal to 0. And for time, we have minus 2c minus 2 equal to 0. So from here we have that b equal to minus 1 and c is equal to minus 1. So we replace in the first equation. So we have that a minus 3 multiplied by negative 1, which is b, plus c, which is minus 1, equal to 0. So we have a plus 3 minus 1 equal to 0. So therefore a, it is equal to negative 2. So replacing back into the relationship for pi 2, we have d to the a, which is to the negative 2, rho to the b, which is to the negative 1, and g to the c, which is to the negative 1, and multiplied by gamma. So reorganizing this a little bit, we have that gamma divided by d squared rho g. So this is our new pi2 number. So our original relationship was h is equal a function of dg rho gamma and theta. Our new function, it is pi1 equal to another function of pi2 and pi3, and pi1 was h over d, a function of pi2, which is gamma, divided by d squared rho g, and pi3, which is theta. So this is our new relationship. So we have only 3 variables, 2 of them independent. So we are going to be able to find out 5 in terms of 2 variables instead of 4 variables, as in this case, much less experiments. Okay, so that's an illustration of how to compute the pi numbers using this technique. Thanks very much.